Okay, so good evening everyone. So yung topic natin for today is regarding beam deflection. So i-define muna natin ang deflection. So deflection is a structural engineering terms refers to the movement of a beam or load from its original position due to the forces and loads being applied to the member. It is also known as displacement and can occur from externally applied loads or from the weight of structure itself, and the force of gravity in which this applies. So deflection can occur in beams, trusses, frames, and basically any other structure. To define deflection, let's take a simple cantilevered beam deflection that has a person with weight W standing at the end. Okay, so ito yung ano natin, no, figure. So meron daw tayo ditong simply support, meron tayong cantilevered beam. And then meron taong nakatayo no dito sa isang end niya na ang weight is W. The force of this person standing at the end will cause the beam to bend and deflect from its natural position. In the below diagram, the blue beam is the original position and the dotted line simulates the cantilever beam deflection. So ito yun, no? So yung deflection natin dito, no, is ito no yung weight due to weight. So ito yung magiging deflection diagram natin. As you can see, the beam has bent or moved away from its original position. The distance at each point along the member is the meaning or definition of deflection. So there are generally four main variables that determine how much beam deflections. This includes, so yung una, loading, how much loading is on the structure, the length of unsupported member, the material, specifically the Young's modulus of elasticity, and the cross-section size, specifically the moment of inertia I. So dito no sa diagram natin, meron tayong cantilever beam or cantilever support sa isang end, and then meron tayo ditong hinge or pin support sa isang end. So kapag nag-apply tayo dito ng force P no sa at dito sa point na to, ang magiging itsura ng deflection natin no is ganito. Hindi siya drawn in scale no, pero ganito yung magiging itsura niya. So ano itong delta equals 0? So yung delta equals 0 natin is ito yung deflection. So ito yung deflection sa point na nandito siya no, sa hinge. And then sa point na nandun sa cantilever end natin. So ang deflection no, sa support natin is 0. And then yung P natin, no, hindi naman necessary na dito at point P is nasa maximum yung deflection natin. Hindi siya necessary no or hindi ganun nag-a-apply yung deflection. So next naman, meron tayo ditong beam na merong dalawang support, merong pin support and merong roller support, and then yung load natin is nandito sa dulo niya. So ano ang itsura nito no pagdating sa deflection diagram natin? So ngayon no meron tayo ditong force P. So anong nangyari dito? So pag alam naman natin ang deflection natin dito is 0. So imagine nyo gumamit kayo ng ruler and then subukan yung i-experiment no na ganito yung gagawin ninyo. So ang mangyayari magkakaroon tayo dito ng slight curvature and then pagdating dun sa second support natin is nandun tayo sa point kung saan tayo nag-start, nakafix siya doon. And then dito no sa point P is andito yung movement natin. So next naman, paano kapag ganito? Meron tayong dalawang loads. So isa no, yung unang load natin dito nasa pagitan ng support and then yung isa naman is nandun sa end. So kapag ganon, so katulad ng diagram kanina, ang mangyayari is magde-deflect tayo dito pababa. And then pagdating sa support natin is babalik tayo dun sa neutral position niya, which is yung deflection natin is equals to 0. And then, di ba, normally, kung wala itong force P na to, ang mangyayari dito, ang shape nito is, ang curve niya, papunta dito, no, going upwards. Kaya lang, meron tayo ditong force P na nagtutulak doon sa beam natin pababa. Kaya ang nangyari dito, kung mapapansin ninyo, is nag-curve tayo dito, no, pababa. So dito pala, no, yung mga, kung saan yung point na ang deflection natin is 0, is yan yung mga tinatawag nating boundary conditions na gagamitin natin kapag nag-solve na tayo, no, ng beam deflection. So kung maalala ninyo, no, yung doon sa yung unang diagram natin sa shear and moments in beam is yung tinatawag nating loading diagram. So ganito yun, no, yung loading diagram natin. Kapag kinuha natin or kapag in-integrate natin ito, ang makukuha natin is yung shear diagram. Once i-integrate natin ulit ang shear diagram, ang makukuha natin is moment diagram. And once in-integrate natin ulit ang moment diagram, ang makukuha natin is yung slope diagram. And lastly, kapag in-integrate natin ulit yung slope diagram, ang makukuha na natin is yung deflection diagram niya. So, punta tayo dito, no, sa beam deflection equations. So, the deflection of a beam or beam deflection is calculated based on the variety of factors, including materials, the moment of inertia of a section, the force applied, and the distance from support. There is a range of beam deflection formulas and equations that can be used to calculate a basic value for deflection in different types of beams. So generally, ang formula natin for deflection can be calculated by taking the double integral of a bending moment equation, so mx, divided by EI or yung product ng Young's modulus natin and moment of inertia. So again, no, yung Young's modulus natin, kung hindi ito given, is nandun ito, no, sa likod ng libro natin. And then yung moment of inertia natin or yung I is kailangan nating i-calculate iyan. So basically, no, ito lang yung sinasabi ng beam deflection equation natin. So yung beam deflection equation daw natin, mx divided by EI is equal to second derivative of y with respect to x. And then kapag kinuha natin, no, yung first derivative nito, so dy over dx is equals to theta. And then ito, no, yung theta natin, isa to yung nagre-represent doon sa slope. And once kapag in-integrate natin to ulit, ang matitira na lang sa atin is y, where yung y natin is yung deflection or displacement. So di ba ito, no, yung mx natin, where mx is equals to moment equation, E is equals to Young's modulus, I equals the moment of inertia, theta is equal to slope, and y is equal to deflection or displacement. So what is the unit of deflection? So ang unit ng deflection natin, no, commonly kapag metric ang pinag-uusapan natin is millimeter or meter, and kapag imperial naman is inches. So this number defines the distance in which the beam has deflected from the original position. So procedure of analysis. So paano ba tayo nag-a-analyze or nagsosolve ng beam deflection problems? So ito na yung mga steps na pwede nating sundan. So una, find the equation of equilibrium values. Next is identify the boundary conditions. Next, cut the beam in different sections to write the mx function for each section. In step number 4, integrate mx twice to write the slope and deflection equation. And lastly, use the boundary conditions to solve for constants. Okay, so para mas maintindihan ninyo, i-apply natin ito sa sample problem. So sabi dito, the beam shown in the figure 12-10A supports the triangular distributed loading. Determine its maximum deflection if EI is a constant. So first step natin dito, no, syempre, given required free body diagram. And then start na tayo mag-solve. So alam naman natin, no, kapag inanalyze natin ito, so uniformly varying loads. So alam natin ang gagamitin natin dito para ma-convert siya into concentrated load, is kunin natin yung area ng triangle. So makikita ninyo, no, dito yung formula is equals to A is equals to 2 times 1/2 base times height. So bakit minultiply sa 2? Kasi pwede natin itong hatiin, di ba, sa dalawang triangle. So next, substitute natin, no, yung mga given. Where yung base natin is L over 2. And then yung height natin is W sub 0. So A is equals to 2 times 1/2 times L over 2 times W sub O. So makukuha natin na yung area is equals to WOL over 2. So next, no, kunin natin yung reaction. So kung mapapansin niyo, no, wala naman ng ibang force na nagti-take effect dito, no, sa beam natin. So mula dun sa concentrated load natin, so pwede nating makuha yung R1 and R2. So dito, no, sa solution, hindi na lang pinakita yung paggamit natin ng summation. Pero pagdating sa end niyo, kailangan kumpleto yung solution nyo. So yung R1 and R2 natin is equals to W0 sub 0 times L over 4. Next step is determine natin yung boundary conditions. So ito, no, yung boundary conditions natin is kailangan nyo ditong i-analyze yung figures natin. Kasi hindi ito given, no, kayo yung magse-set nito based doon sa given sa problem natin. So alam natin, no, so ito, no, yung first boundary condition natin, observe natin, no, x equals to 0, then y is equals to 0. So dito, no, yung boundary condition na gagamitin natin, when x is equals to 0, then y is equals to 0. So ano ibig sabihin nun? Kapag yung x natin, no, is 0, no, so dito sa point na to, yung sa roller support natin, alam naman natin na pagdating sa supports, ang deflection natin is 0. So next naman, na boundary condition natin is at x is equals to L over 2. So ito yon, yung theta natin or yung slope natin is 0. Kasi horizontal line lang siya. So normally, no, kapag ganito, meron tayong, kapag pwede nating hatiin sa dalawang section yung figure natin, is meron tayo dapat 4 na boundary conditions na gamitin. So kaya lang, pagdating dito, no, kasi since symmetrical ito, so since symmetrical itong figure natin, no, so kapag kinonsider natin itong side, so parang nagkumukuha lang tayo ng mirror niya. So imi-mirror lang natin yung side na yon, and then yun na yung conditions. So dito, no, kaya ang nangyari is ito lang yung ginamit na boundary condition. So ngayong na-set na natin yung boundary condition, pwede na tayong mag-proceed. So alam naman natin, no, sabi dito, kumuha tayo ng moment equation. So ang ginawa dito is nag-section. So dito kinat natin yung beam. So pagkakat ng beam natin, ito yung makukuha natin na diagram. So kung makikita ninyo, no, dito sa figure, ito yung nasa reaction natin dito sa roller, WL over 4. And then syempre hindi natin alam, no, yung exact distance niyan or exact length niya ng pagkaputol. So ang representation natin diyan is x. And then, ang ano natin dito, so tawagin natin yung force na nag-a-apply sa kanya, no, na y. So ngayon, kailangan muna nating hanapin yung force y natin. So paano natin makukuha yon? So dito, kung makikita ninyo, meron tayo ditong similar triangle. So dito, no, ang kinonsider ko is yung kalahati lang niya kasi nga, mirror lang, no, or parang mini-mirror lang ng kabilang side natin yung isang side niya. Kaya ang kinonsider ko dito is ito na yung kalahati lang niya at L over 2. Yung W, ang maximum force natin dito or yung height is WO. And then yung length natin is L over 2. And then magkakaroon tayo dito, di ba, ng similar triangle na at length X. Meron tayo ditong height na Y. And then apply lang natin no, yung mga concepts ng similar triangle. So W sub O divided by L over 2 is equals to Y over X. So solving for Y, ang makukuha natin is 2W sub 0 times X divided by L. So next na kailangan natin gawin is diretso na tayo sa moment. Kasi hindi naman natin kailangan dyan yung normal force and then yung shear force. Kasi di ba ang kailangan natin sa beam deflection is yung moment equation. So next no, again ang moment natin is clockwise positive. So ito yung magiging moment equation natin. So dito tayo nag-moment no sa kung saan tayo nag-section. So summation of moment is equals to 0, clockwise positive orientation. So pagdating dito sa cut, ang assumption ko dito is counterclockwise. So since counterclockwise siya no, negative m sub 0. So saan galing itong x over 3? So alam naman natin, di ba, ang location ng centroid natin kapag galing dito sa malaking side ng triangle is 1/3. Kaya lang, ano ba yung length natin? Ang length natin, di ba, is x. So x times 1/3 is equals to x over 3. So bakit naman siya negative? Kapag nag-rotate tayo, opposite direction siya. So since opposite direction, negative. And then, kunin na natin no, yung formula na, kunin natin yung area ng triangle. So ang formula ng triangle natin is 1/2 base times height. So ito yung 1/2 natin. Yung base natin is yung x, siya yung length. And then yung height natin, yung nakuha natin kanina, which is yung y, na 2W0 x divided by L. And then, ito naman no, yung isa pang force na input natin, which is yung reaction. So since same direction, so positive, plus W0 sub, or W sub 0 times L over 4 times X. So simplifying lang natin or kunin natin no, yung moment equation, ilipat natin sa kabilang side. Ang moment equation natin dito, so m sub 0 is equals to negative W sub 0 x cubed divided by 3L plus W sub 0 times LX divided by 4. So ngayon nakuha na natin yon, so proceed tayo. So alam naman natin na ito yung equation natin for beam deflection. So second derivative, so alam naman natin na ang beam deflection natin is equals to mx divided by EI. So kunin natin no, yung i-integrate natin siya sa unang beses. So makukuha natin dyan is yung theta natin. So alam naman natin na i-treat natin as constant itong EI. Kasi di ba sinabi sa problem, EI is a constant. And nagdi-derive tayo in terms of x, so ilabas lang natin yung EI. So theta is equals to 1 over EI times the integral of mx. So cross multiply para mailipat natin, matanggal natin yung fraction dito. So ang ano natin dito is theta times EI is equals to the integral of the moment function natin, which is the integral of negative W sub 0 x cubed divided by 3L plus W sub 0 LX over 4 quantity dx. So dito no, wag niyo kakalimutan yung plus c natin lagi no kapag nag-integrate tayo. And kapag ginawa niyo na to sa end niyo is complete solution. So hindi ako tatanggap ng solution na mula dito no sa form na to is yung sagot na mismo. So ipakita niya sa akin no yung step by step solution kasi hindi naman yung final answer yung tinitignan lang natin kapag nagso-solve tayo. So tinitignan din natin no yung steps or yung approach ninyo sa pag-solve ng problem. So simplifying lang, theta times EI is equals to negative WOX to the fourth divided by 12L plus WOLX squared divided by 8 plus C1. So ngayon no, ito yung equation natin for slope diagram. So mula dito sa equation natin sa slope diagram, i-integrate lang natin ito ng isa pang beses. Ang makukuha naman natin doon is yung deflection natin, equation for the deflection. So kapag in-integrate natin both sides, so kunin natin yung integral of theta times EI divided is equal to integral of quantity WOX4 divided by negative 12L plus WLX squared divided by 8 plus C1 times dx. So YE1 na, or YEI natin is equal to negative WO divided by 12L multiplied by x to the fifth divided by 5 plus WL divided by 8 times x cubed divided by 3 plus C1x plus C2. So simplify lang natin. So y times quantity EI is equals to negative WOX to the fifth divided by 60L plus WOLX cubed divided by 24 plus C1x plus C2. So mula dito no sa dalawang equation natin, i-apply natin ito sa boundary conditions para makuha natin no yung value ng constant. Kasi kailangan natin siyang hanapin. So consider natin no yung first boundary condition when x is equals to L over 2, theta is equals to 0. So i-consider natin dito yung equation na meron tayong theta. So which is ito no yung unang equation natin. So rewrite nyo lang muna no yung equation natin for the slope and then substitute the value. So 0 times EI is equals to negative WO divided by 12L times the quantity L over 2 raised to the fourth power plus WOL divided by 8 times L over 2 squared plus C1. And then simplify natin. So 0 is equals to negative WO divided by 12L times L to the fourth power divided by 16 plus WOL divided by 8 times L squared divided by 4 plus C1. And then simplify. So 0 is equals to negative WL cube divided by 192 plus WOL cube divided by 32 plus C1. So kunin natin yung GCF niya no na or LCD natin, yung least common denominator na 192. So 0 is equals to negative WOL cube divided by 192 plus 6 WOL cube divided by 192 plus C1. So 0 is equals to 5 WOL cube divided by 192 plus C1. Solving for C1, ang C1 natin is negative 5 WOL cube divided by 192. So ngayon, nakuha na natin yung C1. So pwede natin gamitin yung isa pang boundary condition para naman makuha natin yung C2. So when x is equals to 0, y is equal to 0. So gamitin natin dito no yung deflection equation natin na y times EI is equals to negative WO x to the fifth divided by 60L plus WO LX cubed divided by 24 plus C1x plus C2. So substitute natin no yung given na condition. So 0 times EI is equals to negative WO times 60L times 0 raised to 5 plus WOL divided by 24 times 0 cube plus C1 times 0 plus C2. So makukuha natin dito na value for C2 is equals to 0. So next is i-rewrite na natin no yung equation natin for slope and deflection. I-substitute natin yung C1 and C2. So yung slope equation natin, so theta EI is equals to negative WOX to the fourth divided by 12L plus WOLX squared divided by 8 minus 5WOL cubed divided by 192. So next naman, yung slope equation natin, yung deflection equation natin, y times EI is equals to negative WOX to the fifth divided by 60L plus WOLX cubed divided by 24 minus 5WOL cubed divided by 192 times X. So yun na ba yung sagot? Hindi pa. Kasi di ba ang pinapahanap sa atin is yung maximum deflection niya where EI natin is constant. So saan ba nangyayari yun? So sabi dito, we are required to find the maximum value for deflection occurring when X is equals to L over 2. So di ba yun yung based dun sa diagram natin kanina? So ngayon, no, i-write natin dito yung deflection equation natin. So y is equal times EI is equals to negative WOX to the fifth divided by 60L plus WOLX cubed divided by 24 minus 5WOL cubed times X divided by 192. So substitute natin dito no sa X yung L over 2. So ganito yung magiging equation natin. And then simplifying, so y times EI is equal to negative WO divided by 60L times L to the fifth divided by 32 plus WOL divided by 24 times L cubed divided by 8 minus 5WOL cubed divided by 192 times L over 2. So simplifying again, so y times EI is equals to negative WOL to the fourth divided by 1920 plus WOL to the fourth divided by 192 minus 5WOL fourth or L to the fourth power divided by 384. So kunin natin yung LCD nila na 1920. And then simplifying the equation, or y times EI is equals to negative WOL to the fourth power divided by 120. So ilipat lang natin no yung EI doon sa kabilang side ng equation natin. So y max is equals to negative W sub OL to the fourth power divided by 120 times EI. So ganito kahaba no yung solution natin para makuha yung sagot for these types of problem. So gaya ng sinabi ko sa inyo, no? So itong mga equation na to, so ito yung general equation natin. So kapag halimbawa pinahanap sa inyo yung beam deflection niya at L over 4, so substitute nyo lang yung L over 4 dito sa equation natin. So kapag ang pinahanap naman is yung slope natin at x is equals to L over 4, so ito yung gagamitin natin. Eh sir, paano kapag ang pinahanap is lagpas na sa L over 2? Kasi di ba, kinonsider lang natin dito is L over 2. So kailangan natin ditong ituloy pa yung solving, no? I-consider naman natin yung section 2 or yung kabilang side ng figure natin. Pero whereas daw dito sa problem natin na since symmetrical siya, so okay na na isang section lang yung ipakita ninyo. Kasi doon lang naman yung concern. So bakit nyo kailangan ipakita yung isang side na hindi naman natin gagamitin? So basically, no, kapag meron tayong ibang problem na hindi na symmetrical yung figure natin, so magkakaroon tayo ng, kung for example, meron tayong dalawang sections, magkakaroon tayo ng dalawang set ng slope and deflection equations natin. So magkakaroon din tayo ng 4 na boundary conditions. So ganun yung mangyayari. So again, no, kapag nag-solve tayo, ipapakita nyo lagi is yung kompletong solution. So hindi ako tatanggap ng solution na shortcut. No, for example, mula dito sa part na to, For example, no, mula dito sa part na to, and then yung next na pinakita nyo, substitute L over 2, and then ito na yung naging sagot ninyo. So walang credit yung ganun, no, kasi hindi complete solution yung pinakita nyo. Okay, so dyan nag-e-end yung discussion natin for module number 12. Kung meron kayong questions, no, pwede nyo naman ako i-message through Discord or Messenger. And then sa pagsosolve ng TRs natin or technical report, no, kapag ang na-encounter nyo doon is merong regarding shafts, so i-omit nyo na yon. So for example, meron doon 3 problem na regarding shafts, and then isa lang yung for beam deflection, so isa lang yung isa-solve nyo. So salamat.